Assalamualaikum everyone, welcome back to mathematics, and we are solving A level CI's paper Pure Maths 3, paper code 9709, variant 32, May June 2025, and we are solving question number 8, that is about differential equations. Okay, the variables x and theta satisfy this equation, and x equals to 0 when when theta is equals to pi over 12. Solve the differential equation and obtain an expression for x in terms of theta. So how do we solve differential equations? We do separating variables. Separation of variables means we will, wherever there is dx, we will isolate all the x terms on one side, and when we take this d theta on the other side, we keep all the theta terms on this side of the equation. Okay, so 4x plus 3 will shift here. It will become 1 over 4x plus 3 dx, and when d theta goes on the other side, it becomes, and also we take all the theta terms on the right hand side, it will become cos 2 theta over sine 2 theta. What we have done, we shifted this here and this term here because dx is here, so we need all the x terms here, and d theta comes here, so we need all the theta terms on right hand side. Why we do this? Because integration, implicit integration is not possible, that we have multiple variables and we can integrate them. So we separate the variables and then integrate one side with respect to x and integrate one side with respect to theta. So let's integrate this. Now integrating both sides. So it will become integral of 1 over 4x plus 3 dx equals integral of cos 2 theta over sine 2 theta d theta. Now use, what is integral of 1 over 4x plus 3 is your ln of 4x plus 3. Like if you have any expression in the denominator for which the derivative of it is actually 4. So yeah, one step is missing here. We should be having 4 here, the derivative multiplied with this expression, then we can integrate it. So to make it 4, we have to multiply and divide by 4. So multiplied by 4, we are taking inside the derivative integral, and the rest I am taking outside. So it will, now it can be integrated, and the integral of anything in the reciprocal is equals to the ln of that expression. So 1 over 4 times ln of 4x plus 3 equals, how do we integrate cos 2 theta over sine 2 theta? We know that the derivative of sine 2 theta is cos 2 theta. So if the derivative is multiplied, so we can integrate the denominator, the expression, and what is the integral of 1 over sine 2 theta? When the derivative cos 2 theta is multiplied with it, it is ln of, one more thing, there is also the derivative of 2 theta must be there. So for that reason, you must be multiplying and dividing it by 2. There must be 2 here multiplied, then we can integrate it. So it will become ln of 1 over 2 ln of sine 2 theta plus the constant of integration. Now if we need to find the constant of integration, that is very, very important, we will be given any boundary condition, and here the boundary condition that is given is that when x equals to 0, x is equals to 0 when theta is pi over 12. So substituting this will give you the C. One over 4 ln of 0 plus 3 equals to half ln of sine 2 theta. Sine 2 theta means sine of 2 times pi over 12 plus C. What it will give you? Sine of pi by 6. What is sine of pi by 6? One second, let me just rewrite the next step. Yeah, sine of pi by 6 is actually sine of 30 degree, and that is 1 over 2. So we end up getting 1 over 4 ln of 3 equals 1 over 2 ln of 1 over 2 plus C. Okay, now you can subtract this term on the other side. C will be 1 over 4 ln of 3 minus 1 over 2 ln of 1 over 2. Now what we are doing, actually we are not solving it together. We'll just write as it is in the given integration. This is the result of your integration. Okay, we will write this constant C in terms of ln here. We are not solving it for now because we need an expression of x in terms of theta. So what it will give you, I'm copying this and just putting the C here. We don't need decimal values, so we are not solving it. Now what we should be doing, first it is better if you remove this fraction, so multiplying whole equation by 4. It will make it ln 4x plus 3 equals 2 ln of sine 2 theta plus ln of 3 minus 2 ln of 1 over 2. Now we can combine some of the terms together, applying some of the log rules. If you have anything like a log of b, so you can write it like log b to the power a. Like this comes to the power. I don't exactly, this is the relation, like the concept is fine, but we don't write it like this. So it will become ln sine 2 theta square plus ln of 3 plus ln of 1 over 2 to the power minus 2. We are taking this whole as a power. So this will give you ln of sine square 2 theta, because obviously sine 2 theta whole square is actually sine square 2 theta, plus ln of 3. What will be the power? Like if you have a negative power, the fraction flips, so it will become ln of 2 square. Then solve it further, it will become plus ln of 3 plus ln of 4, and then when we have two things added, obviously the logs are multiplied. Actually we have 3 logs here which are added up, so we can multiply their respective expressions. So it could be like this: sine square 2 theta times 3 times 4. So that will give you ln of 12 sine square 2 theta. What we were doing this actually is making one single ln on one side. On the other side we have ln of 4x plus 3. Our whole aim was to make ln on both sides because we need a differential equation x in terms of theta, so we need to eliminate this ln. Now when we have ln on both sides common, we can cancel this. So we end up getting 4x plus 3 equals 12 sine square 2 theta, and x turns out to be 12 sine square 2 theta minus 3 divided by 4. And now you can also distribute the denominator. 12 over 4 sine square 2 theta minus 3 over 4. So that will give you 3 sine square 2 theta minus 3 over 4. This is your x expression in terms of theta. Okay, it seems a little lengthy working, but it's just the simplification using logs. I hope you understand this. In any differential equation, first you have to separate the variables, then integrate them with respect to their respective d theta or dx or dy. Then you will, to find a constant of integration c, we have to put in the values that are given to you. And after finding the c, here you found the c, when you will put this back here, now you have to deal with all these ln terms and arrange it in a way that you get single ln on both sides of the equation, so that you can cancel them out to get rid of this ln. And this is your whole of the working. I hope you understand this. Thank you and Allah Hafiz.